Okay, so in this video we're going to have a look at bearings with trigonometry. Now this is part of the trigonometry series, so obviously you're going to be pretty clued up in your trigonometry to actually tackle these questions, so they are all linked in the description, the entire trigonometry series, but this is also going to involve a good understanding of bearings as well. So what I will do is I'll link the bearings video in the description below, okay, but obviously make sure that you're pretty clued up on both of those before going ahead and tackling any of these questions, because they are quite tough, okay, but we're going to get started on this question. So grab a piece of paper, grab a pen, make some notes, and we'll have a look at this question to start with. So it says two ships leave a lighthouse L, and that lighthouse obviously shown to us on the diagram just here, we've got L. Then it says ship A is on a bearing of 70 degrees from L. Okay, so ship A has obviously gone in this direction over here. There we go, and we've got that 5 kilometre distance there. And then it says, and let's just highlight that, so ship A, and then we've also got ship B, and it's on a bearing of 210 degrees from L, and that's going down here, this 3 kilometres there, down to B. And it says calculate the distance between ship A, and let's just highlight that ship B there with the colour I've just done. It says calculate the distance between ship A and ship B and give your answer to 3 significant figures. So it wants the length of this line here, A to B. Now thinking about how we could actually find that, because we have got a triangle there in that image. Okay, and what we need in order to find that third length there is we're going to be thinking about using sine or cosine. But actually, if we can find one angle, which hopefully you can see is quite a clear one here if you're clued up on your cosine rule, if we can find this angle here, we can apply the cosine rule. So that's the angle that we're looking for, and we're going to think about how we could actually get that angle there. So let's get rid of some of this stuff that I've drawn on there. There we go. So it says that this angle here is 70 degrees. Okay, that's given to us in that first piece of information where it says ship A is on a bearing of 70. Then it says ship B is on a bearing of 210. So if I do that in a different colour, that's going right from that north line all the way round to this line here, and it says that that is 210. So the difference between those is going to give us that angle there within the triangle. Okay, the difference between them is going to give us this angle here. If the full angle is 210 and that part of that angle there is 70, then what's going to be the difference between them? Well, let's work that out. It's 210, take away 70. I'm going to do all this on the calculator. This is going to be a calculator topic, so obviously don't rely on it on a calculator question. We should be able to work out that that's 140 really without a calculator. But there we go, we've got 140 degrees within the triangle. Okay, it's obviously just finding the gap between those two angles there. So let's get rid of that and let's stick this angle in there that we're actually going to use. We're going to use 140 degrees. Now once you've got that angle, to be honest, the rest of this question is quite simple, just in the sense that all we really need to do is just apply a bit of cosine rule, and if you're quite clued up on the cosine rule, you're probably already spotting at how simple that question is. Obviously, if you find the cosine rule simple, obviously that is already quite a high level topic as well, but we have got the angle and we're looking for this opposite side, so that'll be our big A, this will be our little a, and these will be B's and C's. Again, don't worry about the fact that they've labelled the corners of the vertices of the triangle with A's and B's. When it comes to using the cosine rule, you label it as you want. So using the cosine rule, and thinking about what that is again, we've got A squared equals B squared plus C squared minus 2BC cos A. There we go. Obviously the variation of it that I'm going to be using. So let's just plug the numbers in, that's all we need to do. So we've got A squared equals, we've got, let's just write this down, B squared is 5, so 5 squared plus 3 squared minus 2 times 5 times 3 cos 140. There we go, we'll put that 140 in a bracket, that's what comes up on the calculator. So let's just type that all in, and that'll give us our value of A squared. So if we type that in, 5 squared plus 3 squared minus 2 times 5 times 3 cos 140. Let's just double check that, make sure you've typed it in okay. So 5 squared plus 3 squared minus 2 times 5 times 3 cos 140. Lovely, press equals. There we go, and we get A squared equals 56.981. And a few more decimals. We're not going to write them all down because we obviously want the value of A, so we're going to have to square root that anyway. So to square root that then, let's just write that working out down. We're going to do the square root of that, and we get square root answer 7.548. Let's just write all this in. 7.548. How many decimal places or significant figures does it want it to? Let's have a look in the question. So it gives you your answer to 3 significant figures. So I've written down 4 significant figures at the moment, so that's plenty for my working out. There we go. So all we need to do now is chop that after the third significant figure, which is after the 4, and we get our value here of 7.55. There we go. So let's write that down over here. We've got 7.55, context of the question, it's in kilometres, so 7.55 kilometres. Right, there we go, and let's just highlight that. There we go, as our final answer. So just thinking about how we used a bit of bearings there to find the missing angle, and then we just applied a bit of cosine rule, obviously, to find our missing length there. Right, okay, so that is our first question, and here is one for you to have a go at. Okay, so we've got a very similar question here, a little bit more words in the top that you need to read, and a little bit of a different diagram, but it's a very, very similar concept here in terms of what you're trying to find. Just bear in mind that this does say, look, it says A, B and C are 3 villages, and B is 6.4 kilometres due east of A. So just as a little hint for you, due east just means that at that angle there is going to be a right angle on 90 degrees. So there's your little hint. Okay, so pause the video there, have a go, and we'll go over the answer in a sec. Right, okay, so we've already mentioned the first bit. We've got that is going to be a right angle. Then it says that the rest of the bearing from A round to C is 210 degrees. So if we want to find this missing angle here, we need to do 210 and take away the 90. And that's going to leave us with 120 degrees for our angle there within the triangle. So that's 120. There we go. Now we've got all the information that we need. So that's going to be our big A. We're trying to find this distance here. That's A, that's B, that's C, in any order. It doesn't matter if you've done that slightly differently to me, but we get A squared equals 6.4 squared plus 3.8 squared minus 2 times 6.4 times 3.8 cos, and that is 120 degrees that we use in there. There we go. So A squared equals, and if we type that all in, let's have a look. So 6.4 squared plus 3.8 squared minus 2 times 6.4 times 3.8 cos 120, close the bracket, and there we go, we get 79.72. So 79.72. Right, okay, so there is the value of A squared. Now we just need to square root that to find our value of A. So if I do square root answer, and we get 8.92 and a lot more decimals here. So 8.9286. There we go, and a few more decimals, but that's to 5 significant figures. So I want to round this now to 3 significant figures like it asks us in the question. Let's have a look. We'll chop it after the 2, and that's going to become 8.93. And again, in the context of the question, that is kilometres. There we go, so 8.93 kilometres there, and we'll highlight that up as our final answer, and that is the end of that. Right, there we go. Let's have a look at a slightly different style of question then. Okay, so this question here, you can probably already see what's different. We've not got a diagram. So it says 2 ships leave a port at the same time. Let's imagine where this port is. Let's just call it this here. There we go. And it says ship X sails on a bearing of 13 degrees. Now that's not very nice actually. I'm going to move that point because 13 degrees is quite a nasty one to draw. There we go. I'm not going to draw it perfectly, but let's just imagine what this will look like. So we've got a north line going up. There we go. And a ship's going to sail off at 13 degrees, which is obviously a very small angle, but I'm just going to draw it up in this sort of direction there. I'm not going to stress too much about the fact that that is obviously not a perfect 13 degrees there. So ship X sails off and it gets to this point here. Let's just draw another north line in. There we go, and we'll call that X. Then it also says that it goes for 15 kilometres, so I'm just going to put 15 kilometres just there. There we go, just so I can visualise that. Then it says ship Y sails on a bearing of 165 degrees. Now 165 is obviously not quite hitting 180, so 165 is going to go off in this sort of direction. And it says that that's going to go for 18 kilometres. Now I'm just going to label that, in fact I'm just going to shorten that down a little bit. There we go, let's just imagine it's off to here. There we are. And that is 18 kilometres. Obviously this is not drawn to scale because my 18 kilometres there is a lot shorter than the 15, but for the purpose of what we're doing it's going to be absolutely fine, and we'll call that ship Y. There we go. So there we go, we've got our little diagram drawn. It doesn't have to be perfect, but obviously what we're trying to find, it says calculate the distance between ship X and ship Y. So actually if I just move this 15 kilometres out of the way just to help a little bit with this, let's just put that there, because the distance we are looking at is this one here, going between the two. So what else do we need? Well, we've got some angles going on. We were given some bearings. It says 13 degrees and it says 165. So we've got that this bit here is 13. There we are, degrees. I can just about fit that in. I'll try my best. There we go, 13 degrees. And then we've also got the 165 degrees, which is the full angle going all the way around here. So if the full angle is 165, then we can find the gap in between. There we go. I'm just going to label this here, 165 degrees. There we go. That's the information from the question. Now what we want is the angle in the triangle. So from here, look, once you've got the diagram drawn, it's basically exactly the same as what we were doing before. So the mathematics behind it is no more complicated. It's just obviously you've had to draw the diagram yourself in order to get a clear understanding of what you're actually finding here. And again, obviously we're finding this side here opposite that angle. So if we do 165 degrees, just like we did last time, we take away the 13, that leaves us with 152 degrees. There we go, so it's 152 degrees in the triangle there. So let's label that up, 152. And then again, we can just apply the cosine rule like we did before. So let's just label that our big A. We've got our little a over here, which is the x we're trying to find, and we've got B and C, and again, they can go in any particular order. So there we go. Let's just stick all these numbers into our formula. So we have a squared equals 15 squared plus 18 squared minus 2 times 15 times 18 cos 152. There we go. Stick all that in the calculator. Let's see what we get. 15 squared plus 18 squared. 15 squared plus 18 squared. I always forget to press buttons. There we go. 15 squared plus 18 squared minus 2 times 15 times 18 cos 152. And just obviously, just a little tip there, because it's something that I've just done as I'm going along. Just make sure you double check on your calculator that you've definitely typed it in correctly, because once you've got a big long formula like that, you're hitting a load of buttons, it's quite easy just to miss a few. So do go back and just double check it. Right, so when I get that, I get a value of a squared. So we get a squared is equal to 1025, and that's 0.7917. There we are. Obviously we need to do the square root of that again, so we'll square root the answer on the calculator, so square root answer, and we get a length here which is 32.0279 and a few more decimals. There we go. So this is an interesting one, look, because the third significant figure is a 0, so chopping it after the 0, and we get 32.0, and that is going to be in kilometres as it's a distance there. So 32.0 kilometres, and that is our final answer for that question there. There we go. Right, okay, so you're going to do a very similar one to this. There's going to be no diagram, so you're going to have to think about drawing that yourself, and then obviously applying the cosine rule in a very similar way to what I've done here. So here we go, here's one for you to have a go at. Okay, so this question says 2 ships leave a port at the same time. We've got ship A and ship B going on 2 different bearings. Okay, so obviously write down your diagram, have a go at drawing this out and see how you do, but pause the video there and we'll go over the answer in a sec. Right, okay, so here we go. Let's just pick a place for this port to be. So we've got this port here. Ship A is going to sail on a bearing of 333 degrees. Now that's a bit odd, that's very close to 360. So if we draw our north line in, and imagine what that would look like, that'd be around here, look, 333 degrees. So let's just go off in that direction. There we go, and that is going to be our 333. See if we can get rid of that bit, there we go. So that's 333 degrees there, and that is ship A. So we'll call this ship A, and again you can draw a little north line in as well. Whether we need it or not for this question, I'm not sure, but we'll have a look. And that is a 10-kilometre distance there. Then it also says that ship B sails on a bearing of 45, so that is going to go off in this direction, and that's for 15 kilometres. There we go, so 15 kilometres, and ship B is going to end up over here, and again we'll draw a north line in. There we go. Right, so I'm going to move this down. Okay, I didn't realise that it was going to be all going upwards. There we go, so let's just move that there. Right, so all we need to do now is draw a little triangle in. Let's move this 10 kilometres out of the way. Let's move that down there. And let's think about actually drawing this in. So my last line then, just to make that a triangle, goes across here. And we're going to work out that distance there. Now let's see what information we've got then. Now what we've got is it's 333 degrees all the way around there. So that's 333 degrees, and the other information it's given us is that it's ship B is on a bearing of 45, so this one here is 45 degrees. There we go. So this is actually a little bit more complicated than the last one, because we're trying to find out what that missing angle is, or what the angle is within the triangle. Now it's not actually more complicated, but it is different to the last one I've done. Now we've got 45 there, so on the left here we're going to think about how we would find that. Now if it's 333 degrees all the way around as a full turn, we need to find this angle here, and we can do that just by taking it away from 360. So we can do 360, take away the 333, and that leaves us with 27 degrees there to add on. So that bit there is going to be 27, so let's get rid of that, and that'll be 27. Right, so within that triangle there, look, we've got the 27 and we've got the 45, and that is a combined total there. Let's do that on the calculator, not that we need to, but that's going to be 72 degrees. So if I just try and get rid of some of this, let's get rid of that. I didn't want that to disappear. Let's bring that back. Let's see if I can get rid of some of this. There we go. So the total angle there, as we've just worked out, look, is 72 degrees. And that was the combination of the 27 and the 45. There we go, so that is 72. Right, so if you didn't get that step, or you were struggling on that step, maybe you can pause the video and continue with the rest of it. But there we go, that was a bit of a different step to what we did before. But, you know, similar process with your angle rules, think about your bearings. So, opposite that is the length we're looking for, so that's going to be my A and my big A, and then we've got B and C, and again that's in either order. Let's just get rid of some of this, and let's just start plugging that into the cosine rule. So we get A squared equals, and let's see what numbers have we got, 10 squared plus 15 squared minus 2 times 10 times 15 cos 72. There we go, so let's stick that all in the calculator. 10 squared plus 15 squared minus 2 times 10 times 15 cos 72. And we get a final answer here, so we've got A squared equals 232.29, and there's a few more decimals after that. There we go, so there's our value of A squared. So we'll square root our answer, and we get A equals 15.241, let's have a look, 241, a few more decimals, but it wants it to 3 significant figures, so we'll chop that after our third significant figure there, which is the 2, and we get our value of A, which is going to be 15.2, and that's in kilometres. There we go, so 15.2 kilometres, and that is our final answer. Let's just highlight that, and there we go. Right, now before we go on any further, we're going to have a look at one more question, and then you're going to try one of these sort of grade 9 style questions on this topic. So let's have a look at our next one. Right, okay, so before we visit our last question, I just wanted to revisit this question and think about how this would change if it asks for something different. Now obviously we've seen this question before, but we were looking at the distance from C to B. Now I've changed the question this time, said work out the bearing from B to C. So if we have a look at the bearing from B to C, sorry, B from C, then we're going to be having a look at this angle down here, how to get to B from point C. So we're going to try and see if we can work out this angle here. Now we're going to apply a lot of the methods that we did previously in order to get this, because thinking about finding an angle within a non-right angled triangle, we can obviously apply the sine rule or the cosine rule. Now looking at this, if we have a look at this as a triangle, so obviously just highlight some of this, we've obviously got this length here. This length here, we know we can work out this angle here. Okay, this one here, let me just put, I was going to put a little question mark in there, there we go. We know we can work this one out, and then thinking about how we might apply some cosine rule or some sine rule to that or something, how could we actually go about that? Now we worked out that angle, we worked out this length, and as long as I have those two, I can actually do a bit of sine rule. Okay, we can do the opposite pairs here, and we'll have an opposite pair there, or we could actually use the other opposite pair if we were to find the other angle potentially. But the quickest way is going to be for us to just look at a pair that we already have straight away. So actually, if we go about doing some of those steps that we did previously, we should be able to work out any distance or any angle within this triangle. Let's have a look at actually going about doing that, and some of the steps we're going to do pretty quick here because we have already looked at this particular question in this particular format, but let's have a look at how we would go about it. So obviously it said it's due east, so we obviously knew this was 90, and we'd already done 210, take away the 90 to get that little angle inside the triangle, which was 120 degrees, and there we are. So we already know that was 120. We then used the cosine rule to get this one here, so we did A squared equals, let's have a look, the other two lengths squared, so we had 6.4 squared plus 3.8 squared minus 2 times 6.4 times 3.8, there we are, cos 120. Right, there we go. Okay, so I'm going to square root that all in one go, just to get the value of A nice and quick. So I'm going to do the square root of 6.4 squared plus 3.8 squared minus 2 times 6.4 times 3.8 cos 120. Pressing equals, there we go, and we get our value here, which was 8.9286. There we go, 9286. There's a few more decimals after that, but I'm just going to leave it as it is. It only wants my answer to the nearest degree here. But if I label that on there then, so let's get rid of the x, and we've got 8.9286, a few more decimals. There we go, as our little value there. So now that we've got that, now we've used the cosine rule, we've got a pair of opposites. Here we are, those two. And we've got another pair of opposites over here, opposite that angle that we're looking for. So we can use the sine rule now to work out one of the angles, and let's just imagine we could also do the same thing if we wanted to work out this angle over here. Obviously once we've got one of the angles, we can work out all of the angles anyway because it's angles in a triangle. But there we go, let's get rid of that. We'll focus on the actual angle that we're looking for. So when we're looking for an angle, we're going to use the upside down version of the sine rule. So we've got sine A over A equals sine B over B. There we go, sine B over B. So let's just apply all these. So let's say this is A, and this is my little a, and we'll say this is B, and this is my little b. Obviously you can swap and change them if you want. So we've got sine x, our sine A, so sine x over 6.4. What's opposite that? There we go. And that is equal to sine 120. And that is over, what's opposite the 120? The new 8.9286 that we've just worked out. Right, so we can rearrange that. We want to times that 6.4 up to the other side, up to the top there. So we'll have sine x is equal to 6.4 sine 120 all over the 8.9286. There we go. So let's work that out using the fraction button. So 6.4 sine 120, and that's all over 8.9286. I probably could have used the answer button there just to make sure this is super accurate, but as I've left it to 4 decimal places, it's not going to make much of an impact on my answer here. So we get our value of sine x. So we get sine x equals 0.6207, and again a few more decimals, 6207, but we want to find the value of x, so I'm going to do the inverse of sine. So I'm going to get x equals, remember we're doing sine minus 1 here, so shift sine, answer, and we get 38.37 degrees. There we go, 38.37. A few more decimals after that, but it wants it to the nearest degree, so to the nearest degree x is going to equal 38 degrees. There we go, so 38 degrees. There we are. And it does say work it out as a bearing, so there's one more little step on here. Let's just highlight that down there. There's our last little bit of working out. Right, so now we've got that the angle there is 38 degrees, we need to think about this in terms of a bearing. Now remember the question said the bearing of B from C. Now if we look back at C, there's quite a lot of drawing here, so I might get rid of some of this stuff in a second, and we draw our north line in. This is where this question gets really quite tricky, because obviously we've got the 38 degrees, we kind of feel like that question's finished there, but it wants the bearing of B from C. So really what we have to have a look at is the total angle from north, okay, because it is a bearing, not just that angle, so we need to know not just the value of x there, which is now 38, but the full angle here. So if we get rid of that x, we'll put our 38 in there as we've worked that out. There we go. And we also need to work out what the rest of the missing angle is there. Now there's nothing actually too tricky with working that out, but I'm just going to get rid of some of this working so we can kind of see this a little better, and we'll have a think about how we're going to actually approach this, just this final step here. So if we get rid of that, we've got all of this information now. We know that x is 38, we've worked that out, and let's just get rid of some of this writing here, get rid of some of that, there we go. Right, so hopefully you can see this a little bit more clearly now. So in order to find that angle, look, if we think about one of the earlier steps we looked at in one of the bearings videos, and that is just thinking about the angles here within these two north lines, within these parallel lines. And obviously those angles there are co-interior, so we can find this angle here if we can find this angle here, because those two add up to 180. Now that angle there on the right is not too difficult to find, because we've got two of the other angles. We've got that this one's 90, and we've got that this one's 120. We're already told that the full angle there was 210, so we can find this one here by taking that away from 360. So 360, take away the 210 that's given to us, and that leaves us with 150 degrees for that angle there. So let's just get rid of some of this working again. So if that angle there is 150, there we are, that's 150 degrees. given that these two here now add up to 180, that means that this little angle here has to be 30. There we go, 150 plus the 30 makes them add up to 180 as they are co-interior. Right, so now we've got that that is 30, we can now get the total angle of those two. So let's just get rid of some of this again. And let's just think about what we've got there. There we go, so with our full bearing then from north going clockwise from to B, bearing of B from C. So from C here down to that line with the B on, that total angle there is going to be 68 degrees. Right, there we go. So the full angle there, the full bearing is 68 degrees. So obviously our answer is going to be 68 degrees, but not forgetting as well as a final step, it's got to have 3 digits. So that's going to be 0, 68 degrees, and not forgetting that in the final step there. It's always horrible when you finish up a question like this, you've done all this working out, all those steps, and then you just miss out that one last little mark, making sure it's got 3 digits. But that is our final answer, 068. So there's a lot going on in that question. We had a lot of bearings rules, then we had cosine rule, sine rule, and then obviously finding the missing angles using a few more bearings and actually combining that and all, and actually making sure you get the final answer in the end with 3 digits. There's a hell of a lot to think about in that question there, and there's a lot going on and a lot of maths that you've got to be thinking outside the box with as well, because there's obviously you got to be able to think in the moment, what do I need to use here? Do I need to use the cosine rule? Do I need to use the sine rule? So always just try and break it down in steps and have a think about what you're actually trying to find and where you're going with the question. But there we go, that is quite a tough question there. It can't really get much harder than that. These are meant to be very difficult, but that is our final answer for that question. And what we are going to have a look at next is a question very similar to this. Again, we're looking at these sort of grade 9 style questions on this topic now towards the end of the video, but let's have a look at that question for you to have a go at. Here it is. Okay, so on to our last question. Now you may recognise this question as I did this one in my 10 hardest questions across the GCSEs video, which is obviously in my playlists, but this is probably one of the hardest bearings and trigonometry questions that I've seen. It's no harder than the last one that I've done, but obviously that last one was a pretty tricky question. So what I'm going to do for this question is I'm going to give a few hints for it. So if you want to have a go, pause the video, obviously pause the video now and have a go, but otherwise I'm going to write some hints down, and then obviously you can pause it and have a go with some of the hints as well. So my hints for this question, if you haven't already paused it, is the steps in which we're going to have to go about this. Now it says in the question that it wants to find the bearing of Chorlton from Acton. So Chorlton from Acton is over there. Let's have a look. So it's asking us to find the full bearing from here to here, thinking about what we had in the last question as well. It wants it to 1 decimal place, and all the information in the question is given to us. But in terms of actually getting there, you have to think about obviously which angles, which sides you need to find within this triangle, and there's quite a lot of steps to actually get there. Now step number 1 is you can obviously find this angle here, okay, using our, our co-interior angles rule with those 2 parallel lines. So slightly different steps to the last one. We can do this bit first. Once you've found that, you'll be able to find this angle in the triangle here as step number 2. That'll allow you to find that angle there using angles around a point. Once you've got that angle, you'll be able to use the cosine rule to find this side down here. That'll be step number 3. I'm just going to put cosine there. There we go. Step number 4 then, you'll be able to use the sine rule. You'll be able to find this angle here, which is obviously the angle that we're looking for. So if I just put number 4 over there, and that is the sine rule. And then step number 5, you'll be able to get the total angle there to finish it off. Let me just put total like that. There we go. So there's loads of hints there. Obviously you can find all those angles at the top of the triangle to start with, then cosine rule like we did in some of the earlier questions, sine rule then like we did on the previous question, and then again just like the last question you're looking for a total of those 2 angles. So there's my hints. I'm going to stop the video, well I would suggest stopping the video there. I'm going to get rid of these hints and we're going to go for this question. So pause the video there, have a go, and then we'll go over the answers in a sec. Right, okay, so let's get rid of all these hints. Now let's get rid of all that, there we go. Right, so thinking about what we're actually doing here, now some of the things I would probably draw on straight away. The fact that we're going from A to C, definitely the first thing that I'm thinking of. The fact that we're looking for this angle to complete that full bearing there, definitely something I'm thinking about right from the get-go. Now obviously the next bit is the fact that we can't find any of the angles within the triangle. I can't find this one yet because I don't know the one next to it. So straight away I was thinking co-interior angles, we can get that one there. So we can find this angle here, co-interior angles, they add up to 180. So we can do 180 minus the 37, and that gives us 143 degrees. for that angle there. Once we've got that one's 143, we're able to do angles around a point. These three angles here have to add up to 360, so that leaves us with 67 degrees here within the triangle. Now that we've got that 67, we can apply all of the stuff that we were doing in some of the earlier questions, so that really is your little key to unlocking the rest of this question there. You need to get that 67. Now we can do this one, so let's call this little side here A. As I'm going to use the cosine rule, that's going to be my big A, and that's going to be my little b and my little c. So I'm going to do the cosine rule over here to the side. So we've got a squared is equal to 8 squared plus 9 squared minus 2 times 8 times 9. Now we've got the angle cos 67. There we go. So typing that one into the calculator, and I am going to skip a step again. I'm going to square root it all in one go. So I'm going to find a straight away rather than working it out and square rooting it. I'm just going to put a square root symbol over the top of all of that working out. There we go. And it does it all for me in one step then. So we're going to get the value of a straight away. So we've got 8 squared plus 9 squared minus 2 times 8 times 9 cos 67, and just closing the bracket there and pressing equals. There we go, so we get our value of A, and it comes out as 9.4199, and a few more decimals, but it does want my answer to one decimal place, so I'm just going to think about that, and 4 decimal places is definitely going to be accurate enough. So we're going to have 9.4199 down the bottom there. Right, there we go. So now we've got that. Now we can think about finding the angle. So again, thinking about cosine or sine rule, we've got a pair of opposites. Look, we've got the angle opposite the 9, and we've got these two pairs of opposites that we've got numbers in. So we can do the sine rule definitely. Again, we're trying to find an angle, so I want to use the upside down sine rule there for angles. So sine A over A equals sine B over B. There we go, and just plug in the numbers into that. It doesn't really matter which we have A and B as long as we pair up our opposites correctly. So let's go for the first one that we've got a matching pair. We've got sine 67, and that's opposite the 9.4199 we've just worked out. And that's going to be equal to sine x, which is the one we're trying to work out, and that's opposite the 9. Right, so just like with normal sine rule, we're going to times this 9 up. It's going to go up here in front of the sine. So for sine x, we've got sine x is equal to 9 sine 67 all over 9.4199. Right, there we go. So let's work that out in the calculator. So we've got 9 sine 67 on the top and 9.4199 on the bottom. Right, so that tells us that sine x equals 0.8794, and a few more decimals. I'm not going to write them all down though, because obviously we're going to do the inverse of sine now. So sine minus 1 of the answer. There we go. So shift sine answer, close brackets, and there we go. We get 61.5788. 61.5788, and a few more decimals, but again, it only wants it to one decimal place. So there we go. We've worked out that this angle here is 61.57, 61.5788. There we go. So we've got all the information we need now to find the combined total of these two angles. So that combined total there, so we've got 37, add the 61.5788, so 61.5788, add the 37. There we go, and that gives us a total. Let's add those together, plus the 37. Combined total there of 98.5788. There we go, which to one decimal place is 98.6 degrees. And then here's the nasty part to finish this off. Now, although that looks like it has 3 digits, it doesn't. That decimal place does not count as a digit in our bearing. So there's something extra on this little one that we have to think about, and that is just making sure that we add a 0 into the front of our bearing there to make sure it's 3 digits. So it's 098. But then we've also got the 0.6 in there, just giving it that one decimal place accuracy. There we are, so the 3 digits at the start, 098, 0.6, and that is our final answer, And that finishes off our questions with bearings. There we go. So obviously that was a tricky question there. Hopefully the hints might have helped. If not, well then if you did get that. If you didn't, obviously go back through it, go back to the start, see if you can just go back to the start and have a go now that you've seen it me going through it. But that is pretty much one of the hardest questions there. As I said, I did go through this question on my 10 hardest questions on the GCSE video, which you can find in the playlist. But hopefully you found that useful. If you did, please like, please comment, please subscribe, and I'll see you for the next one.